recording and go ahead.
Okay, welcome to our weather watch for Friday the 18th of September. What we're showing you here is Pete produces these great images, movies, and this one is of Hurricane Sally, but of course now it's not going to work because we're live. But you may have seen it when you tuned in, and I'll try and get it to go as I'm talking about it. Yeah, here it goes. This is Hurricane Sally from almost a week ago, 5 days ago, so that would have been Sunday, I guess. And you can see it kind of not particularly well organized off the west coast of Florida, and then there's a period of time coming up right about now where hopefully you can see something resembling the resolution that I have on my screen, and it slows down every once in a while because it's kind of loading in. But right about this time, late in the day on the 13th, you'll see some purple cloud top temperatures. That's really cold, and the thing is really about to explode. So here we go, right there. And then you can see the wide expanse of the really cold cloud tops, some spokes on the periphery, and one begins to see the clear anticyclonic circuit around the hurricane at upper levels. And then later on in the movie, you're going to see some low-level clouds over Louisiana, western Mississippi, places like that, that are obviously moving from northeast to southwest, caught up in the cyclonic circulation in the lower troposphere. So this has been a really great hurricane to look at in the satellite imagery from the perspective of seeing what the vertical structure of one of these storms is really like. Low-level intense cyclonic circulation and an upper-level anticyclone of considerable strength. Well, you really can see that, and time coming up here in a minute. This is about when the storm stalled right off the coast of Mobile Bay, and it was raining like crazy in some of those places. There are some stations, I think, near Pensacola, Florida, that had 21 inches of rain over the whole course of this event, which is simply unbelievable. And rainfall totals throughout Alabama, parts of northern Georgia, and into the Carolinas have been substantial, but especially so down near the panhandle of and northward into Alabama. So it's been a really bad event for them for flooding. And there's water that's still, it's not receded yet in Pensacola and other places in that region of the country. So it's really been a devastating storm. And this was a pretty unbelievable week, widespread across the globe for climate issues and weather issues. We had a giant piece of the Greenland ice sheet go off of Greenland. I'm showing you the current satellite in a minute. I'll say something about it in just a second. We had the wildfires, and of course our skies were illuminated with orange sunsets and sunrises over the course of this week with the beautiful weather we had as a function of the smoke. I don't think you had to use much imagination to see even a gray pall to the sky late in the day on Wednesday and Tuesday especially. So it was unreal. And the satellite movies that we were looking at in 452, 751 during the week were clear evidence in the color image. I'll show you one in a minute, with smoke all over the place. It at one point extended from 1,000 miles off the coast of the west coast of the United States all the way past the Maritimes. So a span of something like 6,000 miles. So these fires are simply unimaginable in their fury. And so that was another aspect of our interesting weather this week. So here's the current satellite movie, and you can see a number of features of interest coming around. This is a tropical depression, or a tropical depression number 22, which may become one of the Greek-named storms by the time this weekend is over, and that's in the southwestern Gulf of Mexico. And some of the forecasts from yesterday had this thing looking as if it was going to take a sort of a Hurricane Bobby track. It may still do so, but it's getting itself organized over parts of the Gulf of Mexico that haven't really been churned up by hurricanes to this point in the season, if I'm right. I mean, that far to the west of the Yucatan Peninsula has been relatively immune. So that's relatively deep, warm water is my guess, and this thing is trying to get itself organized. The main tropical disturbance on this map is Hurricane Teddy, which has recently been a Category 4 storm. I think it might be weakening ever so slightly right now, and it's on a collision course with Bermuda. It's going to go right by Bermuda, luckily to the east of Bermuda as it moves northward, and at least that's the forecast now. And so they're going to get a lot of rain, quite a bit of wind, but not as bad as if the storm were on the west side. And so a pretty intense event. Teddy is going to maybe figure into the forecast discussion because we were talking about it in 452 just yesterday, and at about 140 hours, so something on the order of 5.5 days, that thing was sitting just south of the Maritimes, northeastern Gulf of Maine, and still with a central pressure in the 940 range and a clear, PV tower, a cigar right in the middle of that storm. So it was clearly still a tropical cyclone, and probably a Category 1 hurricane. So I think Halifax is actually going to see hurricane damage from Teddy when it gets up there by about Tuesday afternoon, Tuesday evening. So it's going to be a pretty impressive storm. That's going to be fun to talk about in the forecast. For us, you can't see it so well on this picture, but you can certainly get the impression that there's flow moving from the northwest towards the Great Lakes states, and that is clear in the sky. We finally have a beautiful blue sky again. No more smoke. It's been all washed away, and you'll see that in just a second. And extremely low dew points last night at the end of the day as the cooler and drier air filtered in, and you'll see some pretty remarkably low temperatures were recorded in northern Minnesota and even in our own state last night, and they may even get exceeded in the coming evening. So it's a really nice cold spell that's hit us right at the beginning of the season. So let's go next to a color image of this. And this is only in the last 12 hours, just a few pieces of it. But you can see, obviously, the smoke that has now been pushed a little bit southward from at our longitude into southern Illinois and Missouri. It occupies the entire Great Plains states from the Dakotas down to Texas. And then everything to the west, all the way to the coast, is clearly smoke pall all over the western United States and southwestern Canada. And you can see even some evidence of smoke out ahead of this frontal system that passed through us. Here it is right here where the cursor is, out over the Atlantic. That's all western smoke from the fires. And that was what was over us earlier in the week. And there's Teddy just creeping into the edge of this image, and tropical depression number 22 down in the Gulf of Mexico trying to get itself organized. So a pretty interesting weather map all across the board here, all these different things that we're able to see at one time. So let's go next to the West Coast, and we have to use the infrared because, you know, it's that time of day. We can't really see anything in the visible except in the last couple of hours. So there's a cyclonic circulation off the Oregon-Washington coast. I have a friend in San Francisco who was celebrating, I guess, 2 days ago or maybe a day and a half ago with a beer at the Fisherman's Wharf because finally the sky wasn't orange and it looked nice and clear. So this kind of southwesterly flow has ventilated the immediate coastline of California and Washington and Oregon, I think, to some extent, which is welcome, I'm sure. Because for a period of time earlier this past week, it wasn't just that the fires were burning, but there was no substantial wind in the boundary layer or aloft. And so the smoke was sitting still. And I think that's really disastrous for air quality. So people were probably succumbing to that, those who have respiratory trouble. And I don't think if you have respiratory trouble, you want to be in a country that's screwed up the COVID-19 response, because that's one of the ways that it really gets you is in your lungs. So this is a disaster on multiple levels, and hopefully there's been a little bit of relief from the way that the synoptic situation has evolved on the immediate coast of the western part of the United States. Out to the west, to the date line and further to the west, you see there's not really anything particularly well organized in the mid-latitude westerlies. There's evidence in this cloud mass that's now spilling into the Yukon Territory and far northwestern British Columbia. That was a really nicely organized storm on about Wednesday into early Thursday morning. Central pressure was down below about 980. I think it was below 980, so it was in the 970s. Pretty decent looking storm, but of course it was raked over the coals, as it were, over the Coast Range in Alaska and British Columbia, so it just got shredded. And there's not much of a disturbance upstream of it to speak of in this satellite movie. So it's kind of a period of inactivity over the Eastern Pacific. We're entering the point in the year where those periods of inactivity become less and less frequent, and things get really charged up there. So that's exciting if you're a person like me. So here's the national radar scene, and you can see some of the precipitation coming onshore in southern Louisiana and just offshore of south coastal Texas associated with a tropical depression number 22. And some of this looks fairly intense in terms of its convective activity, particularly given how far offshore these echoes are. They're pretty far off. They're almost at the limit of the range, and yet they're still showing up pretty intensely. So that's a decent feature to keep one's on. It's not going to be benign for very much longer, most likely. And then here's the clouds and precipitation, I should say, associated with the frontal passage of a storm that took its time coming across the eastern United States, took most of the week actually to do so, and yet it provides insurance for the immediate coastline, provides insurance against the incursion of Teddy. Bermuda is way out here off the map, and Bermuda is going to barely get hit by it, and that's largely a function of the fact that it's going to turn northward and to northwestward today, and then it's going to run into this frontal boundary, and by about 5 days from now, you'll see it really attach itself to that, just like Paulette did to this frontal boundary, but further northward. And it'll really turn it into an interesting looking structure with a tropical cyclone embedded within an occluded thermal structure. Really, really interesting by the time we get to Tuesday and Wednesday. Okay, here's the Hurricane Center. I'm going to update this because I think some of these things have suddenly gotten names. Let's see if that's right. This is the one off of, oh, it's just off the map. Subtropical Storm Alpha is off the coast of Portugal. And this was as of 4:30 p.m. Greenwich Mean Time, so almost an hour ago. Go ahead.
Yeah, you can actually click on that if you wanted to see the track of it. That's interesting.
Oh, yeah, look at that. Right into Basque Country and then the Bay of Biscay. So that's going to be interesting for the northern Spaniards and places in northern Portugal. Right here, you get the greatest waves on the earth, actually, because there's a trench right off the Atlantic coast. That's Nazaré in Portugal. So if the winds kick up, that'll make it even more interesting as Subtropical Storm Alpha makes its way across the Iberian Peninsula. So that's pretty neat. And there it is right there. So we're already into the Greek alphabet, literally days, less than a week past the peak of the Atlantic hurricane season climatologically. So we're onto our 27th storm with a name, which is unbelievable. This is a prolific season thus far. And there are a couple of other disturbances. This is just an easterly wave that's coming across the west coast of Africa. They're talking 0 chance of cyclone development in the next 2 days, but keep your eye on it. These waves are important. And here's one well in the North Atlantic that's got some chance, but probably a very little chance of development. Here's 22 that we saw on the satellite picture. Wilfred is way out here, somewhat orphaned in the Atlantic, just past the Cape Verde Islands, but you've got a 35-knot wind, tropical storm. It's probably going to find itself developing a little bit into the future. And Teddy, of course, is the 115 knots. That's Category 4, Bailey Category 4, or just the top of Category 3. I guess I don't know that so well. So it's a pretty strong storm. And there's Bermuda, that little dot in the middle of the western Atlantic Ocean. And Teddy is forecasted to, as you can see here, maybe you can see it, forecasted to go right past Bermuda and then up to the Maritimes. It is still a hurricane when it goes there. It's not a tropical storm until it's crossed over to Prince Edward Island. So it's going to be really interesting. And the structure of that particularly is going to be interesting. So I'll let Michael say more about that probably because he's going to do so in the forecast. I'll start now focusing more on what's going on over us because though we don't have exciting weather in terms of drama, we have beautiful weather in the offing, and so it's worth paying attention to that. So here's the 6Z forecast, and this is valid. Oh no, this is the analysis. Sorry, I did change that. So this is the 12Z analysis from this morning's run. 1,032 millibars right along the Mississippi River on the border between Wisconsin and Minnesota. That accounts for the lack of winds outside today, and absolutely still perfect postcard day for vacation in September. You know, it's too bad we're always in school in September because this is about the nicest month of the year in southern Wisconsin, if you ask me. And so here we are, absolutely beautiful day. Anticyclone of 1,032 millibars sitting right over us. Look at the thickness gradient that drapes right through the middle of it. Much cooler air. This is the 540 thickness line where my little cursor is, and that's clipping the northeastern part of our own state, and very chilly air. And so the cold advection actually, over Michigan, Ohio, parts of New York State, and so on. And we're just about at the transition. A day from today, we'll be back in the southwesterly flow. So this is going to be a really beautiful windless day for us. And if we look at the surface map at the same time, so it's not the current surface map. I took this one on purpose, not only because it has isobars drawn on it, you can see the 1,032 millibar isobar right where it was in the analysis, but also because you can get a sense at 12Z of something close to the minimum temperatures, and without looking at individual stations one after another, one gets a decent synoptic view of what really happened overnight last night. It got cold. It was 21 degrees under clear skies at International Falls this morning with a dew point of 18. 21 degrees. I saw no indication at the in the forecast Weather Service forecast office Duluth that that's a record. So it's been colder than that on September 18th apparently at International Falls, but 21 is darn cold. 30 at Duluth, so they got below freezing. The whole northern part of Minnesota was below freezing, actually. Several different stations in this wild wilderness. We got to 27 north of Wausau, 34 itself at Wausau, 44 at Madison this morning with a dew point of 41. Look at how the lake has made it 11 degrees warmer with a slight onshore wind at Milwaukee. Pretty impressive. And the wind is just a little bit off of the Green Bay, so it's kind of off the land here at Sturgeon Bay, 39 degrees, or Green Bay, I guess, 39 at Green Bay. And so widespread temperatures at or below freezing, and certainly below 40 in a lot of locations. Pretty incredible for the 18th of September. So that's relatively neat. Let's go to some other parts of the country. Why can't I move it easily? All right, well, let's do it this way. So here we are down in the land of tropical depression 22. So you can see it's not surprising. Dew points are high. Temperatures are just a little bit above the dew point. So solid tropical saturation down along the coast. It's not raining at any of these stations as we saw on the radar, but it is raining further to the north and east in the remnants of, there is the remnants of Sally. So it's raining along the coast in Norfolk. It's not raining. It doesn't seem like at Washington. So it's maybe more along the coast than inland. And some of the stations in the central part of the state, like Raleigh's got light rain. And then a little bit of rain over the island counties of Massachusetts, all along the combination of Sally and the frontal boundary that's down there. Does somebody have a question? Maybe not. Okay, and then let's go west, where we had that cyclone, fairly shallow, not an intense storm, off the coast. There's smoke in southern Oregon. We've seen this for the second week in a row. Some stations reporting smoke. We don't see that symbol too often, but this time of year it's this year it's been pretty widespread. And then a lot of obscured skies all over the place, but no precipitation in any of those stations. There's smoke at Spokane, so smoke in southern British Columbia, so unbelievable. Smoke on Vancouver Island, many smoke symbols going on across the country and the adjacent country of Canada, which someday we'll be able to visit again, we hope. Okay, so that's just a little quick roundup. I was particularly interested in the cold temperatures and the relationship to the anticyclone over us. So look at these pressures: 1,032 near Grand Marais, 1,030.8 at Wausau. So we had a pretty high pressure here today. Okay, that is also related to the infiltration of cold air in the middle and upper troposphere. So here's 850 millibars from this morning at 12Z, you can see. And the 0 degree isotherm cuts right across Lake Winnipeg, cuts off the arrowhead of Minnesota, goes through halfway of our state, half of Michigan, and then clips New York State and northern Maine and parts of the other New England states. So that's really, I was told a long time ago, wherever 0 degrees is at 850, that's where autumn is. And we're 3 days away from the equinox, and we're just about seeing autumn beginning to invade. So this looks climatological. It's about what it should be, even though we've been relatively cool the last couple of days, and we will be over the weekend. Incidentally, I looked it up today. The last time we were 80 degrees in Madison was September 2nd. So that's only 2+ weeks away in the past. The all-time earliest last 80-degree day for Madison is the 4th of September, 1977. So if this 80 degrees on September 2nd stands as the last time we see that temperature, which I highly doubt, but if it does, it will set the all-time earliest last 80-degree day ever in Madison. Now, I should point out that the mean last 80-degree day in Madison over the last, I think, 70-some years is September 29th. So we're not that far from the mean day. And the all-time record latest 80 was October 23rd, 1963. So there's a huge variation. We can go almost to Halloween and have 80 degrees, but not quite. And yet we've not had one since September 2nd. So that's interesting. And just as I'm on the subject, a little recap of the summer. It's likely we won't see 90 again this year. We had 10 days at 90 or greater this summer, and 8 days at 89. So if you take half of them, we're talking about something like 14-ish days right around 90 degrees or higher this summer. And that's about the climatological average. I think we're supposed to average about 13. So it was right about an average summer by that regard, that particular measure. So let's take a look at some other levels here at 12Z. We'll go to 500 next. So here's the upper trough that's really responsible for the pooling of cold air in the eastern part of Canada, and it's brushing just just to our east, actually, more so than over us. But it's a really deep upper trough. Go ahead.
Speaking of cold air, this is Ketzel.
Yeah, hi, Ketzel. Hey, congratulations on your new appointment.
Thank you.
Yeah.
As far as International Falls goes,
Yeah.
their cold weather this morning, at 20 degrees, they actually tied their coldest low record, which was in 2012.
Oh, that's great. So they did tie it. 2012 is an interesting year too, because that's the year of the ice minimum in the Arctic, and we're going to see something later on. So that's very interesting, and they got to it on September 18th, 2020. So 20 degrees, that's pretty cool. So they they tied an all-time record.
Yeah, and Duluth and Hibbing broke their old low records, and Ashland also tied theirs as well. So,
wow. And that's with a northwesterly wind at Ashland, so they were off the land pretty much.
Yep, which makes a huge difference. But that
Yeah.
previous record for Duluth was from 1929.
Wow, that is awesome. Almost 100 years ago. That's great, Ketzel. Thanks for adding that.
You bet.
So here's our 500 millibar map. So this upper trough did deliver the goods in some of those stations in northern Minnesota, breaking all-time records for the date. That's great. You can see an intense upper level front. Temperatures in central Quebec are minus 30 or colder all the way in this northern 2/3 of the province. And then along the coast here at Halifax, it's minus 11. So we're talking about 20 degrees. Most of that concentration of that contrast concentrated maybe in 2/3 of that baroclinic zone. And this is lengthy. It goes all the way from the tip of Greenland almost down to Lake Huron. So this is a really intense upper level front. And it's part and parcel of the fairly intense development we had late last week, and that's taken its time to get into the Labrador Sea. It's been a stormy period, and we've been just south of a lot of that storminess. But if you were in southern Ontario this last week, you would have kind of thought that this is a really early winter. And then the upstream, this is the weaker cutoff that we saw in the satellite off the west coast. And then it's wavy all the way through Canada and across the Aleutian Island chain at 500 millibars also. Let's see what it looks like at 300 for the jet. So here's a really intense jet that goes all the way again from the east coast of Greenland down toward about Montreal. And that's the eastern side of this upper trough. And Sally, of course, is about here. And so some of this jet is a function undoubtedly of the outflow from the tropical storm, steepening the tropopause and intensifying the jet streak. Other than that region, the winds are quite weak at 300 millibars, about 100 knots in the trough off the Aleutian Island chain, barely 90 rounding the base of the trough off the west coast. And let's go to 200 for the simple reason to see what is it really like. And it turns out this jet on the east coast is pretty clearly connected to a subtropical jet. You get this high, you're not going to mistake a polar for a subtropical jet. So this thing is subtropical jet, and I'd say all these pieces that are over Western Canada and in the Gulf of Alaska are also pretty much a subtropical jet. So I'm sure Greg has some comments to make here, but I would begin the comment period by saying that here, just as the polar night jet begins to rev up around the equinox, we see no evidence at all of a polar jet over North America. It's all subtropical jet, and that's aided by some of the hurricanes, but even absent the hurricanes, I think that's what we would have at the end of this period of just before the equinox in the spring. I mean, in the fall.
Well, let me say that I hate to do this, but I think I'm going to disagree with you again.
Wow, excellent.
And I think these polar jets actually do look pretty polar. I've been looking at them on my plots, and they don't seem to have very much low potential vorticity associated with their southern side at all.
Oh, okay.
So I think they actually are, but the jet stream you were talking about over there on the east coast, the southern part of that is the outflow. So that one is subtropical, but but the rest of it I don't think is.
Oh, that's good. I mean, you have a more refined analysis. I'm basing it just on whether it gets stronger or weaker as I climb to higher elevation, and it looked like it didn't get weaker by anything substantial. So I'm glad to have that comment. That's interesting. And so this might be the first footings of the polar night jet kind of finding its way down to lower elevation, perhaps. I don't know if that's the case.
Let me change that. I don't think it's the polar night jet yet. The polar night jet is much higher, and the polar night jet's up there like 20, 30 kilometers, right? But this just doesn't seem to have any low potential vorticity like you would get from the tropics on the southern side. It's
Yeah,
probably, as I've always said, an old subtropical jet,
Hmm.
but at this point, it looks like it's mostly got middle latitude polar characteristics. The polar night jet has not appeared yet, at least at 40 meters per second. I went down and looked all the way down to about 30 meters per second yesterday, and I still don't really see it. So I don't
Yeah.
think it's there yet. It's going to take another month.
Yeah, that's not surprising. I guess I would have expected that it was maybe beginning to show up at 30 meters per second around the equinox, but not at 40 probably for a while. So, okay, that's really interesting. So this is maybe pure polar jet, weak though it is, and it's weak just because it takes you got to get pretty far north to find the cold air right now, except over our longitude where it's all the way down to the lakes.
John?
But that's unusual. Yeah.
I don't know. I don't want to interrupt your flow of things, but I was actually going to make a comment somewhat related to that during the forecast discussion when I was starting off. If I could just briefly share a map with you. This is from
Yeah.
Pete's map collection. I'll be brief and then
Sure.
I'll let
So
you
I'll
wrap up.
give you the screen. Let's see. Okay.
All right. This will also be just good quick practice for me. Hold on a sec. Should be coming up in just a moment. So this would, I think I fit somewhere in between what the positions you and Greg were talking about. Can you see that?
Yeah.
So here's Pete's tropopause maps. This is just from the initial time. That kind of corresponds to the, well, it does correspond to the 12Z time. This is the map that the same map time you're looking at on
Yeah.
the Super Pete. And you can see, I don't know if you can see the cursor, just along the New England coast. You can see that bright red splotch right there. And I
Yeah.
think as you can see sort of plume-ish type structure that's emanating from Gulf of Mexico all the way up along the east coast, and I guess just to the west of Bermuda, this broad area of very high potential temperature, I think is part or largely the outflow, as you're suggesting, from Sally.
Mhm.
And then when you go in, go into New England, across New England into southeastern Canada over Ontario and Quebec, you can see that temperature gradient continues, and you get to these colder temperatures down to 291 Kelvin along the dynamical tropopause. And so maybe this blue area kind of outlines where the polar jet is, and sort of the close proximity between the polar and tropical jets is this broad area of winds that we see from New York State into the Canadian Maritime to just south of Greenland. I think that's what we're looking at right now.
That's very reasonable. I don't have it to show, but in my preparation I looked on Tropical Tidbits, allows you to draw these nice cross sections, and there's no doubt there's a double jet along the line from, say, east of Hudson Bay out towards Bermuda, and so it's just exactly like what you're talking about.
Yeah, and then the other is it subtropical, is it polar? Maybe what Greg is getting at is you don't really see some of those really warm-ish colors, yellows and bright oranges, in this region over parts of Canada and just south of the Aleutian Islands. And so this temperature gradient here is probably going to be associated with maybe a polar jet as opposed to subtropical in this region.
Yeah.
When you define your subtropical jet or your polar jet, it's what theta values do you typically use again?
315 to 330 is the layer in which we're looking for that.
Okay, so I can't make it up. That's maybe the blue range right here, where you have that strong thermal gradient and the strong winds. It's probably outlining some aspect.
Yeah, it seems to fit here because, I mean, you can see much colder thetas, 291, but when you're in the lighter green, that's probably in the 315 to 330 range. In fact, I know that it is, so yeah.
Okay.
Can I put my map up where I could show you what this looks like to me, right where I see it? Just in contrast, real quick.
Yeah, I think the floor is yours, Greg.
Okay. I can get it up here.
The digital floor.
My digital floor, yeah. Okay. Make this a little bigger. Okay, so here's this map from this morning at midnight, and these are the jet streams, 40 meters per second or greater. And here on the east coast of North America, can you see this okay?
Yeah, it looks like a little weasel.
Yeah, it looks like a little weasel. But you could see this colored area on the southern side and how you could see a little convex, a little ridge thing on the south. That's the outflow
Okay.
right there. So you can clearly see it as a separate entity that's merged into this uh, polar jet with the blue and light blue colors, and then that comes around here. These are polar. Now we have some subtropical jet over Asia and Eastern Asia coming off the coast over there, and these look very different, right?
Yeah.
Because they got
Yeah.
they're merged, they're a stream. I think the better way to define a subtropical jet is look at it as a merged stream of tropical air and polar air with high potential vorticity and then low potential vorticity on the other half. So it's kind of split between the two, and they merge together, and that's what you see here: blue on the northern side and yellow and red on the southern side. Then in the southern hemisphere, you got subtropical jets over here, and this is the polar night jet down here. So that's a
Oh
monster.
yeah. Okay. Okay. Yeah.
And you can see these subtropical jets kind of merging into the polar night jet as we see when we get deep in our winter. This is what happens. This is left over from their winter still, but it's still a pretty significant entity down there. But we don't have anything like that up here yet.
Not yet.
So, and if I just animate through that, you could see how this goes.
Yeah. Very interesting.
So, you see how these are connecting in southern. So I'll let you go on there. I won't take any more here.
Okay. Thanks.
Mm-hmm.
This is working really well. Having 3 different screens come in at various times is not at all a problem. And I'm almost done with mine, so I only have a couple more things to show. Where's my, here we are, we're back here. Okay, so let's move on to, this is really interesting set of maps I think that's worth looking at today. So this is the sea ice extent as of yesterday, and in the northern hemisphere, right at the pole. And you can see the orange line here that I'm showing you on my with my cursor is the median ice edge over the last 30 years through 2010, and this is the ice edge in white right now. And it was just this week that a 42 square mile piece of ice broke off right in this location. So now it's set adrift, which is a fairly big piece apparently in Greenland. So we're way below for the day the median ice extent. It's especially true in the eastern hemisphere. The waters in the Arctic Ocean north of Siberia and parts of Russia and even Alaska are way, way below ice from where they usually are. So that's interesting. And then here's the ice concentration. So you take all the pixels and you figure out how much of it has nothing but sea ice. That would be 100%. How much of it has 20% ice and open water and so on. And that gives you this shading of blue. When you get to 0 ice, of course, it's the ocean, and that's the darkest blue. So you see that even on the edges of that ice extent, especially true just north of Alaska, this is really slushy. It's not really icy. It's icy along the Greenland coast, but it's slushy in other places. So this is thin ice, even at the extremely recessed extent that it's showing on this map. So that's kind of unbelievable. Bad news. And then here's the sea ice extent, and we're reaching just about our annual minimum. The record season is 2012 is the dashed green. I think it's a green line, black maybe, the dashed line. And the peak was, the minimum was right about September 17th or something like that year. And it looks like we've just done that again this year. Not quite a record, but darn close. And look at the interquartile and interdecile range in the gray, the darker or lighter gray shading in the mean from 1981 to 2010. We're some 2 million square kilometers of less extent of sea ice in the northern hemisphere, and this is becoming routine. This is an exceptionally bad year, and so Ketzel, it's funny that the records in northern Minnesota were set around this time in 2012 before this situation, and we got a hemispheric picture of a different variable that looks very similar to that two years comparison, 2012 and 2020. So that's kind of interesting, I thought. And then I think the last thing I want to show you is not that. Is, I'm 18 days now, 17 full days into my annual charting of the cold pool extent, the -5 air at 850 over the northern hemisphere. And so here in the 3 darker lines, the black line is the 1951 to 1980 average. The green line is 1981 to 2010, so I'm using the sort of climatological 30-year averages. And then the blue line in between is the long-term average from the NCEP reanalysis, 48 to 2014. That's the aerial extent of cold air at 850 millibars that's colder than -5 degrees C over the northern hemisphere. So a 10 means 10 million square kilometers and so on. We're entering the period of most abrupt increase in this aerial extent of the entire year. It ends about the beginning of December, and then it flattens a little bit. It continues to grow, but not at quite the same rate. And here's this year, September 1st through the 17th. So we're already way below the average aerial extent of the -5 air. These are daily averages that I put on this chart. And I'm kind of intrigued as years go by whether the integrated departure from September through November 1st has any bearing on what happens for the rest of the winter. I don't know yet. I need somebody who's smarter than me to help me figure this out, but I have a ton of data, and it'd be fun to just jump into it and try and understand whether or not a reshuffling of, let's say you have I now have 72 years of September 1 through December 1, and they can be ranked, which ones are the coldest, which ones are the warmest, and then how do they shift, how do they flip into December through the end of February? And what is the factor that makes those seasons with the biggest shift from either being cold in the fall and warm in the winter, or warm in the fall and cold in the winter? Why do they shift? I don't know the answer to that. Maybe it's chaos, but maybe it's something less than chaos. And anyway, we're already running a deficit, fairly substantial one for this year compared to the average, no matter how you consider the average. So that's all I have for the current weather right now. If there's any questions or comments before we turn it over to Michael.
John, before you turn it over, question, just curious if you could add on to this, a plot of this sort for each day, what the record low was. It may be different years, certainly, just to get a sense on each day what the lowest was for that day, and then also maybe just the record low integrated year so people can keep track of that as well.
Yeah, that's a great idea. Yeah, I think I can do that. That would be a fun project.
Yeah, these are really interesting maps or charts to look at to see that extent. And I think the question you're asking about, just the relevance of that departure, integrated departure, where I think you were saying November or December, how that relates to the complexion of the winter ahead is really interesting.
Yeah, and I'm afraid it might be more chaos than anything else, but maybe not. And if the maybe not is what makes it worth trying. So, yeah, but that's a great suggestion, Michael. I can work on that. I'll try and get those for the next time I show it. I'll probably show it every couple of weeks, and then I'll try and put something like that on next time. That's a great idea. Okay, let me give you the screen then.
Okay, I'm going to do this. Hopefully I don't lose anything here. And for those of you in 141, has this come up yet? Can you see a map? Yeah. Okay.
Yep.
So we're going to start off with just a quick chart. This is from the Pivotal Weather site that shows on National Weather Service current hazards. There's some other links that we could go to for this, but this just shows the current hazards over the continental United States, and they're color coded. So these red areas are reddish areas, magenta areas are red flag warnings. So this is, a concern about the dryness and the possibility of fires. Flash flood watches in Western Oregon, and that's kind of, at some level, it's a nice thing, but it's also a hazard. They're getting rain there, so we saw that weather system that was off the west coast that's going to produce some light precipitation over Oregon with that southwesterly flow. It hits up against the mountain ranges, and I guess it can just rain out. And that can, with lots of recent burning, that can certainly mean less vegetation to oil in place, and so when you get that rain, you could get some flooding. And then the northern parts of the upper Midwest, we see these blue areas and light blue areas over the Northeast. And those are freeze warnings and watches that have been issued by the Weather Service offices there. And then finally, in the southeastern part of Virginia, we see flood warnings. That says the remnants of Sally, with the considerable precipitation that passed, moves out into the southeastern, or just off the east coast of Mid-Atlantic. And you can see a lot of rivers are experiencing some flooding. You can see these green areas that are over the southeastern United States, and a coastal flood watch that's been set up from central Louisiana, all the way back to eastern Texas with an easterly flow, an onshore flow ahead of that developing tropical cyclone that's out over the Atlantic. So the first thing I want to look at before we get into the current weather, and we're going to kind of do things kind of telescope down from sort of long range to short range, but just go back to the tropics for a moment. And this page that I'm introducing you to is a page from State University at New York at Albany. This is Brian Tang's site. It has a lot of interesting products for looking at tropical cyclone forecast. This first map that we land on his page shows the location of some of the active tropical cyclones. It gets updated during the course of the day. It hasn't been updated to show that this investigation area, is associated with alpha, subtropical storm alpha. But you can click on any of these, you can get some sense of the track of the tropical cyclones. And we're going to look at Teddy initially and look at some of the forecast tracks associated with Teddy to start off with. So click on that and it gets you to these probabilistic pages. The 0Z ECWF forecast is one there. This is what's called an ensemble forecast, or the output from an ensemble forecast showing the track. The ECWF has 51 tracks. I can't see questions or comments. Oh, thanks, Pete, for sharing that. This shows, the ECWF 4 times a day runs 51 forecasts out with slight differences in the initial conditions to elicit a sense of the spread in the forecast. How sensitive is this forecast to changes in the initial conditions? And by looking at that, you can get some sense of the probability of a particular event occurring at a particular location. If you have 51 realizations of it or forecast of it, you can then take the average, look at the mean, look at the distribution of the forecast. In this case, we're looking at the forecast tracks that Brian Tang has processed. And this color coding just basically shows the probability of a tropical cyclone passing within some distance of a given location on this map. And so these deep red colors are almost a near certainty, in the 80 to 90% likelihood that tropical cyclone will pass within this range, and then it drops off beyond that. Also shown on here is the official forecast, which is the solid black line, and then some of the verification since the last forecast was observed. We're just plotting the points for that, for the verification. And you can see this really looks like, in terms of ECWF forecast, this is headed for Halifax, Nova Scotia. But areas all the way out to St. John's, Newfoundland, are perhaps going to be in a, if you were to develop a cone of uncertainty based on these probabilities, would all be within that. The official Hurricane Center track, again, through 120 hours, pretty much follows pretty closely to what the ECWF forecast has. If we look at the U.S. ensemble, GEFS ensemble, and we'll go to from 6C last night, you can see a very similar track in the forecast. The ECWF, or sorry, the GFS actually has the forecast track well to the east of where the official forecast that the Hurricane Center is projecting, but then it bends it back toward the west, back toward the east coast. Then you can see considerable scatter beyond that time period out to a week as it moves into north into eastern and maritime Canada beyond that time period. It's really a great site to look at if you're interested in looking at hurricane tracks from the dynamical forecast models in addition to what the Hurricane Center is projecting. But obviously for any official information, you want to look at the Hurricane Center track. So going back to the sort of the long range outlook, let's first start, as I always do when we look at the forecast, I'm going to first start with our, actually I'm going to go back to the long range because I think this is kind of neat. This is the tropopause potential temperature map for the that Pete has created, and notice he's also nicely added some of these vectors. Can you hear me?
Yep.
Yeah, we can
Okay,
hear
to make
your.
okay, to make sure
We got
still
better.
connected. Okay, so I'll bring this back to the beginning, and we'll step through initially just to look at a couple things. So we saw this map earlier in our discussion. You can see the outflow from Sally, the upper tropospheric outflow, the really high potential temperatures. And if you were to look at the moisture content, well, you can see the high potential temperatures associated with the outflow from Sally all the way out into the North Atlantic. To the very eastern edge of this map, you see this broad area of very high potential temperatures. This is the outflow, the exhaust, if you will, at the tropopause from Hurricane Teddy. It's kind of an odd name for a storm, but that's what it's called, from Teddy. And he'll probably be a bear of a storm as he barrels toward the vicinity of
my God.
Bermuda. And then
That's great.
to do it. I had to do it. Then if you go to just the Atlantic, the Gulf of Mexico, western Gulf of Mexico, you really can't see much yet from that depression that's newly formed. But you do see evidence of an upper trough. This is, we'll look at some other more traditional maps in a second, but this green area right here indicates, you can see the change in curvature of the flow. There's an upper trough. These lower potential temperatures along this dynamical tropopause indicate an upper trough. And so you can see that. And that's some shear in the northern Gulf of Mexico that the forecasters see is influencing development of this, or hindering the development of this right now. But we'll see in the forecast this actually begins to lift to the east and gets away from the storm, and so the storm can then begin to develop later this evening and tomorrow. So if we step ahead a little bit, you can see that trough begins to move out. But the other interesting thing, I'll go back a couple steps, is what's happening out here in the Atlantic from the outflow from Teddy. You can see this really increasingly anticlinically curved region outflow with increasing potential temperatures. As you can see the cursor. And this is, again, a nice broad anticyclone over and ahead of the Hurricane Teddy. And you can see this warmth move eastward, approaching the latitude and the location of Bermuda. Also, you'll see right on the east coast this huge surge of very high potential temperature as the subtropical jet extend all the way to just south of Iceland. So this is really warm air in the upper atmosphere and lower stratosphere that's progressing toward Europe, and we'll see this from a different perspective in just a moment.
Hey, Michael.
Flow from Teddy. Yes, John.
This map is so dramatic in that it shows that I don't think there's a place in the Pacific Basin where, or longitude in the Pacific Basin, where the tropics invade to the same latitude as Reykjavik in the North Atlantic, with a routine, sort of occurrence here in the hurricane season. So you'd have to be, where would you have to be? You'd have to be north of the Bering Strait to have the same sort of latitude, and yet there's tropical air that's clearly lapping up against Iceland in this map. That's just unbelievable.
Yeah, this is really dramatic. There was a case study that was done, I think, 5 to 10 years ago. I can't remember the name of the tropical cyclone that Lance Dart and some of his collaborators, I think Andrea Lang may have been on that as well, that looked at one of the tropical cyclones that went all the way up north of Japan into and east of Siberia, that pumped up the tropopause in a dramatic fashion just like this. But yeah, it's rather rare to see this happen in the Pacific, and we're going to see a global view of this in just a moment.
I think it just has to find, the Pacific jet is so zonally oriented most of the time that it just doesn't have the opportunity to find these longitude bands where it can punch poleward. And in the Atlantic, it's just the opposite. You've got a southwest to northeast oriented jet. It kind of leads you to the high latitudes by nature. It's so interesting.
Right. Yeah, that's actually, so, what's the structure of the jet, or, before these events occur, it allows it to punch through more easily in the eastern Atlantic. And maybe, the zonality of the Pacific jet says something, but then what are the other aspects that allow this to break through? I think that's an interesting question.
Yeah.
So we'll step forward again. And the key thing is, you can see the outflow from Teddy stays, again, right off the east coast. Oops, I didn't want to do that. Sorry. I'll just keep clicking. And you see that red area. And then you can see it begins to get more structured as it begins to interact with this little trough that moves off the east coast just south of New England. And just watch carefully what happens. We saw those tracks in some of the GFS and the ECWF forecast kind of bending back toward the west or the tropical cyclone. You can see how this upper trough that moved off the east coast begins to kind of undercut the latitude of the hurricane. We'll see this in a forecast map. You can see this ridge that begins to build across eastern Maine and Nova Scotia and eastern and in Newfoundland as well, as this outflow begins to curve back toward the west. And it's flow like this that can actually bring that tropical cyclone back toward the west, toward the eastern parts of New England and the Canadian Maritimes, which I guess is going to be a concern in the forecast. And look at that, just really dramatic outflow. You can see the development of huge ridge just ahead of the tropical cyclone. So that's
awesome.
Really interesting. And we'll see what that looks like at the surface in a moment. These are really nice maps that Pete's put together. So you can see this really big punch. And as we were talking about just briefly in our chats earlier this morning, John, this kind of looks a lot like an incident that occurred back in 1991, which was the so-called perfect storm when it was Hurricane Grace.
Grace. Yeah, Grace.
Was undergoing an extratropical transition, interacted with an upper trough just off the East Coast, and created a huge storm with very low sea level pressures and lots of wind and coastal erosion associated with it. There's also been some talk on Twitter, people that follow this, that people are speculating, is this kind of like what happened with Sandy? It's a little bit of a different story, but it has some elements with the broad ridge that develops north of the cyclone, but I think that was a pre-existing ridge in the forecast. So that's the evolution of this cyclone.
That's awesome.
But yeah, and the other thing I'll just note as I step through this again, if you look at the weather map, you don't see much in the way of really strong thermal contrast over. I mean, you see the strong thermal contrast along the dynamical tropopause out over the Atlantic. You see surge coming in over the Pacific. North America, it really is rather flat. And I can't see the chat sort of coming in. Oh, that's Pete. But you can see that indicates that we're going to be under a period of rather quiet, tranquil weather over the next several days. And we'll look at that when we look at get to the surface maps in just a moment. So again, this is going through 81 hours. We see the tropopause gets a little bit higher, so it's getting warmer at the dynamical tropopause, but not much happening in terms of really strong gradients. But the other feature I want to point out is this surge that comes in across the Pacific. You may have seen that as I've been clicking through. Another map. This is the hemispheric view of this dynamical tropopause. And for those of you taking fluid dynamics classes like 310, or have taken 310 and 311 that are now seniors or grad students, you talk about geophysical fluid dynamics, you can really see the fluid nature of the atmosphere. I'll stop this at the beginning. Same sort of map we're looking at now. We're getting a much broader perspective. And if I dare try to shrink this a little bit, if I can.
Michael, you can use the arrow keys to go forward and backward on that. Right will go forwards, left will go back.
Yeah, thanks. And so you can see this feature that's coming in across, just approaching the Aleutian Island, sort of mid-latitudes and high latitudes. And this is outflow. It's unclear if it's from a tropical cyclone, at least initially. It does appear the surface map that a tropical cyclone gets involved, but look at this warmth along the dynamical tropopause, which is a broad anticyclone that moves toward, it begins to approach the west coast, prevents that upper trough that's in the Gulf of Maine from getting to the coast, and this spreads across southern Canada. So this is a broad ridge that eventually arrives at our longitude. If you look at the time here, this is just over now and stays over a while. Eventually, we begin to see some disturbances from lower latitudes invade and give us some precipitation. But it's just really a dramatic surge of air, and it's probably going to see a lengthening of the subtropical jet across the Pacific. You can see this really tight thermal gradient. That's probably going to be a very elongated subtropical jet, not particularly straight. It's going to be a long ribbon of the subtropical jet across the Pacific. To verify that, I'll quickly go to 250 Pascal and show that. I have not looked at this, so this will be it's probably a good level to look at. It'll load up. And then I'll start just a quick loop.
Yeah, and this is the time of year. This is the time of year when the tropopause polar vortices have been weakened to their worst extent, by the summertime radiation. So it's too bad, because if you could link one of those up with the subtropical jet, that'd be a pretty exciting North American weather week. Oh yeah,
most definitely. And another really neat thing to note here at this map. This is 54 hours. This is Sunday afternoon. Look at this upper trough. Look at Teddy out here in the Atlantic, and just watch it as it approaches. That it begins to interact with that upper trough, and it just gets flung back to the west, and then gets caught up in the jet, and then just begins to create a racing jet toward the northwest part of the Iberian Peninsula later on in the forecast. So this is just kind of ramps up. So these tropical interactions with higher latitudes can lead to intense jets briefly during this time of year, and they can basically propagate information and weather systems downstream quite rapidly.
Yeah.
So a source of
it's so interesting. Last year when we were in Munich, I think it was the first week of October, and we had a remote experience looking at the jet over North America when we were over in Europe, and it was over 200 meter per second jet, I think, just off the coast, and it was one of these interactions. So unbelievable.
Yeah. So I'm gonna quickly go to John's favorite map, the meteorogram, for the short-term forecast. We'll look at the surface map. So you can see in the short term, our forecast is for temperatures basically increasing over the next several days. And you can also see dew points stay relatively low, and it's dry. In fact, the GFS forecast for us keeps us dry for for a fairly long period of time. I don't want to look at that. Let's get rid of that. Also, I want to introduce another webpage I think Pete has up. This is thanks to Isaac Schlussi, who's created real-time WRF run, and we have the computing facilities to do some really high-resolution 9 and 3 kilometers runs over North America and over Wisconsin. We'll have that later on this semester. But we have our familiar time height sections, the meteorograms that are so key to look at. And you can see the short-term forecast from 6E last night for Madison keeps us with an easterly wind through basically tomorrow morning. And then we begin to get southerly winds as our warm-up begins. But also for this particular forecast, we stay dry. I'm going to stick with, just because it's the more recent forecast, surface. Let's just quickly look at a loop surface map over us. And you can see the large anticyclone that just remains in place over us, then slowly heads toward the east into eastern Canada. The yellow lines on this are the 1,000 to 500 millibar thickness contours. You see precip every 3 hours, the accumulated precipitation, every 6 hours. And the most conspicuous features on this map this morning are the tropical cyclone that develops in the western Gulf of Mexico. And its track in this particular model run, it brings it in near Houston with lots of rain. So very heavy rain expected along the Gulf Coast. But again, for us over the weekend, relatively quiet weather. We're going to have a nice anticyclone over us and a slow warm-up. If we look at the time height sections, again, another nice tool to look at. The yellow contours here are potential temperature, and you can see the creation of a nice well-mixed layer over us during the afternoon today. And that was also the time period when our dew points dropped, so we mixed out. Overnight tonight, we see from after 0Z post-sunset. Sunset today is at 7 p.m. You can see the isotopes beginning to sort of pop back out of the ground, if you will, as we get that radiational cooling overnight. Relative humidities go up a little bit. And then we mix out tomorrow afternoon with some sunny skies and some subsidence over us as the anticyclone begins to head to our east. And you can see the winds staying southerly over the period. We don't get as cold tomorrow evening as we get tonight, and then we warm up again nicely on Sunday, brisk southerly winds. So again, a big warm-up is expected for us over the period, but it will stay rather dry. Looking beyond the weekend for us, again, there's not much weather-wise over us. Just quickly look at GFS for complete things. If there's something people would like to look at, we can focus on that. I want to bring up the surface map. Again, a very similar story. If you look at the location of the tropical cyclone in the Gulf of Mexico at 60 hours, GFS, you can see a track that's a little bit slower. It keeps it just south of the Houston area in this particular model port, but at 993. But again, this remarkable swelling anticyclone that was over us this morning, over New England, protecting them at least initially from this tropical storm, from the Hurricane Teddy that's out there. Again, a really quiet period in the forecast. And if we just jump ahead to early next week, we go to 90 hours. There's a tropical cyclone just on the edge of the map. You can see the thickness trough associated with the upper trough just east of New England. But again, we're in a really quiet pattern of just warm advection over us and a westerly wind, west-southwesterly wind. I know if you wrap this up. So I'm going to look at total accumulated precipitation over this period. You'll see the rain in the Pacific Northwest, where they have the flash flood watches out. But for us, this is through 90 hours, not much. Go through 168 hours. So this is through Friday morning. We stay dry. Lots in the Gulf of Mexico with a tropical cyclone, but this is a dry pattern for us after last week's rainy period and this week's relative dryness. You see, we finally do get some precipitation once we get into next weekend, unfortunately, if this model is to be believed. So big thing is dry and mostly sunny for the entire period. There'll be clouds, but we're not going to get much in the way of precipitation until we
I think
get
that's good
to-
for the farmers. Don't they need things to dry out at this point?
Yeah, for harvesting things and for haymaking, I presume. So nice things again in the longer term forecast, if this verifies, is a wetter pattern for the western part of the United States, not all the way down to most of California, but certainly the Pacific Northwest is going to finally get wet. But John, having gone to school in that area, this is typically a dry period for them. Is that correct?
Yeah, you don't start school in Seattle until this week that you're showing on the forecast map for that reason. The summer lasts until the end of September, so it'll be perfect. People will be going back to school on the first really rainy weekend, after the first rainy weekend of the fall, which they'll love. Yeah.
Okay.
But then they won't see
So
the
again,
sun again for months.
Right. So in short, this is, the period, the weather over us is going to be dry and generally pleasant for the next week or so, with increasingly warmer temperatures. Not getting super warm, would probably be in the low to mid 70s. Most days probably in the 60s, and overnight lows in the 40s and low 50s. So nice weather to get outdoors if you can and be socially distant and safe. But
Are we back to having smoke again? Ooh, it looked like like 2/3 of the western part of the country is still pretty smoke covered. We just have a respite today from this kind of polar intrusion.
Right. I think once the winds turn more to the west on Sunday and particularly Monday and southwest, will probably bring some of that smoky air back in. There are, I guess, work model forecasts that have that out, but I know that was shared last week. I think it was Berkner shared that. I don't have the link, but that might be something to look at. Anyway, unless there's something folks would like to see, I haven't seen the comments. I don't want to go over or respect your time. People have classes coming up. That's it. Again, thanks again for the opportunity to share some of this, and thanks, John and Pete.
Thank you, guys.
Thank you, Michael. Thank you, Pete.
Yeah.
Thanks everybody for showing up, and Greg, thanks for your stuff.
Yep.
See you all next week.
Let me make an announcement to my class to reconvene on our own Blackboard site at about 1:10. So take a little break.
All right.